Hello friends, I am Mohit Verma and my project is Butterfly Valve. I have three members in my group, Amandeep Verma and Subinder Singh Sidhu with me. So our project is on Butterfly Valve. So Butterfly Valve is an actuator valve in which we have a revolving disc inside the housing. When the disc is parallel to the flow of the water, it allows the fluid to flow. But when it is perpendicular to the flow of the water, it blocks the flow of the water. So here is our design, which we have designed in Fusion 360. We have a main outer shell, and then we have a valve disc, which is inside the shell, and then we have shaft, the handle, and the rivets, and the nut and the bolts. So in this model, we used, here is an exploded view of our model. The disc goes from the upside and the shaft goes from the right. We have an outer plate which is used to stop the shaft inside the shell. We have the nut and the bolts which are used to connect the valve with the pipe assembly, and then we have a handle which we have designed to attach to the shaft using simple keys. We have also designed the gaskets, or we can say it seals, so it will not allow the leakage. So here is a video how our valve works. So when it is parallel, it allows the flow. When it is perpendicular, it blocks the flow. So we applied some DFM techniques on our project. Earlier the disc design was like this. It has a hollow hole in the center and which has a threading inside it, and the shaft is the shaft also have the threading, and it is inserted in this hole. But the disc we designed is a circular plate with the two holes. The first hole is smaller, you can see, and the second hole is little bit like a slot and little bit bigger. We give it like little bit tolerance so that we can easily assign the holes with the shaft holes. So we applied the DFM technique on the shaft also. Earlier the shaft is like this. It is having threading. The threading process is a time consuming process, and it also use some of the gears to revolve it. But our shaft is a simple. We can machine it using simple turning operations, and this slot can be easily made using planer. And we have a key slot over here, so it can be assembled with the handle. So we have two holes over here so that the valve disc can be riveted over here. So we use the DFA technique in our project also. Earlier the assembly was very time consuming. It have some gears, it have a thread assembly and the actuator in the handle, so it take lot of time to assemble a valve. But our design is very simple. We have a shaft and a valve which are joined with the rivets, and a handle which are joined with the keys, and can be easily joined with the pipes. So here is what we did with the shaft and the valve. We designed a new shaft and the disc valve so that we can easily we use the rivets instead of the threads. So rivets are used to hold the disc with the shaft, so it will be easy and less time consuming. And we have made the second hole little bit bigger, so it will not take time to align the holes in the position. So second, we in DFA we did like something with the handle and the shaft assembly. We put a little slot in the shaft and a little slot in the handle, and same in the handle also. So we designed two keys, so it will be easy to join the handle with the shaft. So now I will take you to my model. So here is my model. You can see we can rotate this and we can put this in parallel position and the perpendicular position. This position is parallel to the flow of the water, and this position is perpendicular to the flow of the water. In this position it allows the fluid to pass, and in this position it will block the flow of the wall. So we have done some machining on the parts. So it is the valve disc. So you can see the machining process. And we did the machining process for the handle part also. So thank you, that was our model.